Hello and welcome to Transform Tuesday. I'm Dave McCormick, VP of Product Management here at Alpha Software. And today I am very excited to be continuing on with our Internet of Things series and as it relates to Alpha Transform. So today we're going to cover that topic. I'm also here to answer any questions, which you can type into the questions box of the GoToWebinar control panel. Now, it looks like I am flying solo here today, so if someone could let me know whether or not they could see my screen and hear my voice, just type that into the questions box. I would appreciate it. And once I see confirmation that you all can hear me, we'll keep going. Okay, wonderful. Thanks very much. All right, so it's been a few months since we covered Internet of Things, at least in any detail. And so I want to do first a very quick review at the beginning of this presentation, but then we're going to take what we've done a little bit further on. So let's begin with where we left off. So we were talking last time about how Transform Central, of course, can collect information from people typing things into the Filler app on the phone, or now with the new desktop Filler. But it can also collect information from Internet of Things, in other words, from sensor devices and other things using the API. Oh, it looks like Sarah's joined us. Hang on a second while I add her back in. All right, wonderful. Sarah is also here. She is our Director of Customer Success. She's also in charge of our documentation. So any questions you have, she'll be happy to answer. Again, just type them into the GoToWebinar control panel. So anywhere, back we are with connecting sensors. Sensors have become very inexpensive, as have these microcontroller and microcomputers. Although there's a bit of a caveat at the moment, the price for these things is crazy. I'll tell you about it in a second. They'll come back down in price. I wouldn't worry about it too much. Now, what we did was we created a system using Python. Python is probably the preferred language for Raspberry Pi computers, these microcomputers that we're going to be talking about today. And what we did was we created two things. We created a script that will run on the Raspberry Pi, and we wrote that in Python. And then we created a web service in Alpha Cloud, which is Alpha Anywhere, that took information from that Python script and used it to write information directly into Alpha Transform using the API. Now, the reason we went through Alpha Cloud into Alpha Transform is it lets us clean up the data. It could also let us aggregate the data, and it can also allow another layer of security. So we can do authentication against here to the Alpha Cloud web service from the Raspberry Pi, and likewise Alpha Cloud uses the API key to talk to Alpha Transform. There are some good arguments for not putting API keys on physical devices like the Raspberry Pi, which is one of the reasons we decided to use the intermediate web service. Well, enough about that. Let's just talk about what it actually does, and that is it sends over, use a JSON object with a temperature and a humidity encoded in JSON into a web service. The web service then creates a new form in Alpha Transform, one that's been set up for that purpose. And then Alpha Transform, once it's successfully created that form instance, sends information back to Alpha Cloud, where it comes back down to our Python script, and our Python script acknowledges that the record has been added successfully. So to do that, we needed to have a form in Alpha Transform, which really only needed to have two fields. There is the temperature field and the humidity field. And then based on that, we could write our script. And we did that using Python. Now, Python, just as a reminder, you can get at python.org. It is an open source programming language. It's one of the most popular now in the world, and it seems to be gaining in popularity. Right now they're at 3.10. I think 3.9 though is the one that a lot of people still seem to be using because the libraries haven't all caught up with that. And I'll tell you about libraries here right now. Libraries are extensions to Python that let you do things that are not built directly into the Python language. Now, when you download Python from python.org, you'll also get an IDE type of program in it called idle, and that'll let you create and edit scripts in Python. It'll let you run your scripts and stuff like that. It's available on just about every platform that exists. I happen to be running it on my Mac. Of course, it's available for PC and for Linux and for other operating systems as well. When I fired up the Python IDE, I just created a simple hello world script when I said print, and then single quotes, hello world, and I got back an answer right here in the shell. For those of you who've used Alpha Anywhere, this is very similar to its XBasic interactive window, and it's a good way to sort of test out commands. But you can also create, by going up here into the File menu, a new file and actually create a script. And this is the script that we wrote to talk to our web service. It's actually really easy. The first thing we do is we import a library. I just mentioned that a moment ago, and we import a library called JSON. When you import JSON, you get a bunch of functions that now let Python work with JSON objects. And so what I did with that JSON function was I first created a string, and I set temperature and humidity in the string. And you'll notice I formatted it like a JSON object. And then what I did is I took that and I put it into a JSON object using the json.dumps command. And it took my string and turned it into an object. The next thing I did in my script was I imported a separate library called requests, which we'll come to in a second, what request does. And what I did was I took the JSON that I had created and posted it to a URL, to a web service that I had created in Alpha Anywhere. All right, moving on to the next slide. Just want to tell you quickly about requests. Requests is a really, really cool library. Lets you do all kinds of great stuff in Ajax. You just import it into your script and you can use it. As you could see, in just one line is all it took, basically, for me to create an Ajax callback. So it does a lot of stuff underneath behind the scenes for you. And it's very, very convenient to use. All right, so let's move on. Once I had wrote that, I just went into idle and I chose run module. And the result was that I got back some information. And the information was what was returned by my web service, which in turn is what came back from Transform. And it shows that there are no errors and that my record was added successfully. And in fact, if I go into Alpha Transform, or if I went into Alpha Transform, I could take a look and see that, yep, sure enough, there's that temperature and humidity reading, and there is a new form that was created just for that purpose. Okay, so I'm going to talk very briefly about the web service in Alpha Anywhere that I used to create this. And that's because we have a lot of content on building web services in Alpha Anywhere, and it would be just too much for me to cover, especially today. But basically what I did was this web service basically looked for in the body values that have been submitted to it. And I pulled out basically the temperature and the humidity. I then formed a string that I would use to talk to the Transform API. And then I swapped in the values that I got from the body into that string. And then later on, you don't see it, but I posted to the Transform API using the API key. We do have other videos on that we can share with you on how that is put together, but I'm not going to do that right now. But the practical result is that when this web service is called and you pass it in a temperature and humidity, it will create a new form in Transform. Transform will give back the results showing that it was successful, and this will then return the results back to the web service that called it back in Python. All right, so that's cool, and you could see that it worked, but so far I was only really working on my Mac, so that's not really a great proof of concept. The question is, how do we get it onto one of these guys here, one of these Raspberry Pi computers? What you're looking at here is the Raspberry Pi 4. They are supposed to retail between $5 and $40, and even the $40 is supposed to come down to $35. However, there's been a supply chain issue with the silicon, and you can read all about it on the Raspberry Pi Foundation website. So there's a little bit of price gouging going on. Now is probably not the time to pick up a bunch of Raspberry Pi computers. They won't break the bank, but they are not in the regular price range that they expect. And we expect in a few months they should probably return to where they were before. Interestingly, one of the Raspberry Pi computers, if you want to order it even today, has not been outpriced, and that's the Raspberry Pi 400. What this is, and this is actually the one I'm going to be using today, and that's the reason I'm bringing it up, is it's basically a Raspberry Pi 4, one of the later models, and it's been embedded into this keyboard, and it comes with a mouse, or it can come with a mouse and a cable as well, and the SanDisk to make it work, the SD card. So let me show you what that's about. I've actually set up in my office here. This is my office very alpha. And I've set up a separate workstation just for working on Raspberry Pi and hardware stuff. So that's it right here. And what you can see here is a Raspberry Pi 400 computer. It's just plugged into a monitor. And you can see up on the screen if there's a graphical user interface, which comes part of the standard operating system that comes with a computer. And the important thing is that on the back of the device, we have access to all those pins, those GPIO pins, which are what are going to let us connect to sensors later on while you get to the electronics portion. On the back of this computer, you'll also see a couple other ports back here. There's a USB-C port, which is now supported, so you can run a SSD drive off it if you will, if you wanted to. A couple of USB ports, 2 HDMI ports, and this is key right here. This is the memory. So think of this as the hard drive and the RAM and everything, not the RAM, but the hard drive basically of the computer is right here on this memory card. It's one of those memory cards you might use in a camera or in an audio recording device. And when you get this package, it's pre-installed with a version of Linux called the Raspberry Pi OS or Raspberry OS. And that includes just about everything that you need. Now, the idea is that if we start building stuff out here, we can test the electronics on the same machine that we're working on. And when we're done and we're happy with what we have and we know we've got a working system, we can make a duplicate of this SD card. And that SD card can go into another Raspberry Pi, a smaller, less expensive one that we actually connect up the sensors to. So that's what we're going to do in future webinars, but let's keep going with the Raspberry Pi so I can give you kind of an introduction to how it works. Now, like I said, I do have a setup here just for working on the hardware portion of it, but to be honest, I kind of prefer working at my regular computer for doing a lot of this programming stuff. So what I wanted to do is connect to this computer and run it what's called headless, where it doesn't actually need a keyboard, a mouse, or a monitor. So to do that, I'm going to use actually a piece of software called, or a system called Virtual Network Computing. You could think of this as like remote desktop, or you can think of, which is, the Microsoft solution for logging into your computer, or you can think of it as go to my PC or log me in or something like that. But basically what it lets you do is it lets you open up a window, and here's my viewer window, and actually take direct control of the computer. So you can put the computer in a closet or somewhere like that and go somewhere else. As long as it's on the same network, as long as you can get to it on the network, it's there. So to get this set up is actually really, really simple. And I'm just going to walk you through the steps right now. Basically, what you're going to do is you're going to get a client for your computer. Oh, I thought I had a picture of that. I guess I don't. Well, I'll do a live demo and I'll show you how that works. Basically, what we're going to do is we're going to switch on the ability to use VNC. This is a capability that's already built into the Raspberry Pi. We just have to enable it at the BIOS level, and then we will install or use a client on the computer that we'd like to connect to. So why don't I just pop over to a live demo right now. Let's take a look right at the Raspberry Pi. And I've got it here running here in this program called VNC Viewer. All right, here we go. So here in VNC Viewer, what I did was, and this just comes out of the box like this. So as soon as you log in, well, there's a little bit of setup with a Raspberry Pi, but it's very similar to setting up like a Chromebook or a PC. So it's going to ask you things like, what's the keyboard layout? What language do you want to use? What time zone are you in? Just sort of the normal things you do when you set up any computer. When you're done, though, it'll drop you off here at this interface, which is the graphical user interface that comes with Raspberry Pi. It's kind of like Windows in a little bit of a sense. Like it's got a start menu, which has got different programs and stuff built in here, and it has something that's very much like a system tray, as well as the clock and the status bars. So the first thing that you're going to want to do as soon as you have finished doing the configuration with keyboard and time zones is you're going to want to open up Terminal, and this will drop you down into a command line interface. And this command line is actually in Linux. So I can do things like the ls command to take a look at what's here on the hard drive. Keep in mind the hard drive is really just an SD card. And what I want to do, though, is I want to first turn on the ability to use VNC. That means I'll be able to then use this computer from whatever computer I wish to use. So to do that, I'm going to type in the command sudo, which tells it that I am the super user and I'm allowed to do what I'm doing here. And then it's rasp config. And what happens is when I open this up, or I hit enter, is it gets me into basically the BIOS settings for the Raspberry Pi. The change that you want to do in this case is you want to go down to interface options. You're going to push enter for select, and you're going to go down to VNC for virtual network computing. And I already have it set to yes, but it's going to be set to no by default. Just use the arrow keys to move it to yes, and you could hit enter. I'm going to escape out of here. It's probably going to give me an error, but I don't care. That's fine. But what you would do is you would press enter to make those changes permanent. And then you would go ahead and reset the Raspberry Pi computer. I think I found that it doesn't work until you actually reset the computer, which you can do very easily up here by saying log out and then reboot. I'm not going to do that. Once that's done, all you'll need to do is install a client on your computer. And the one that I used is called VNC. Oops, let me get out of this mode. Is called VNC Viewer. Here, I'll go to the About. And this is available for, so it's at realvnc.com. And this is available for every operating system, pretty much. So we'll just click OK. I just want to show that to you. Now, in order to connect to realVNC, I had to first tell it what the IP address was of my Raspberry Pi. That might not be something that you immediately know off the top of your head, but you can find out again here in this terminal window in Raspberry Pi. And the way you do that in terminal is by typing IP space A. And here it gives you a whole bunch of information, but I actually have got a slide in which I've blown that up for you so that you can see what you actually need to see. So let's pop back here to PowerPoint. And down here, see where it says iNet? That's what you're looking for, 192.168.1.52. So that's really that's the connection. Once I've entered that into my VNC viewer, it's going to ask me for the username and the password for the Raspberry Pi. You'll know that because that's the thing that you set up when you first configure the Pi. It asks you to change it, or you can leave it as the default. So that's that. Once that is done, you are ready to connect remotely. And what I did when I connected remotely is I went in here and I went to the Raspberry Pi menu and I went down to the section called Programming. And you'll see there's a lot of stuff that's, there's Node.js comes with it. There's there's Python, there's Scratch, and you can install basically any programming language you want. So what I'm using here is, instead of the idle IDE, I'm using something called the Tani Python IDE, which I've opened up right here. And actually, I kind of like this one. It's the one that comes now on the Raspberry Pi. It used to be idle. And basically what you do is you just hit plus and it creates a new tab. You can enter in your script here and save it. And you can run it just by clicking run. And if you want, you can debug your script, which is super handy, over here by hitting debug, and it just moves through line by line and lets you examine what's going on. It shows you in the shell window what's going on. So all I did here was I basically just took that script, which I had shown you earlier on today, and I pasted it here into this window. And then when it was there, I just hit run. So I hit run current script, and you'll see that that shell here is being updated. And right now it says no error, and it's introduced a new record. Let's go ahead though and change the temperature or something like that. I think the temperature today where I am is about 21 degrees Fahrenheit with humidity of around 33%. Let me go ahead and save that. And now let's run that script. It's running. So it went and talked to the web service, then wrote that record into Transform, and we got back a success. So with that done, let's go over to Transform and see if it worked. So here I am in Transform, and the form type that I've chosen is the IoT sensors form, the one I showed you before. And I'm going to go ahead and refresh and have it look for new records. And it looks like there are a couple of new records. One was basically the two I just submitted. One was the original one with the 7542 value. And then down here with the new values, 22 and 33. So that is basically what I wanted to show you today, how to get this running on Raspberry Pi and have it talk to the server. Now, there are a couple other things that we're going to cover in some future episodes, one of which is how to get this to run basically completely headless so that the moment the computer is switched on, it already knows what script to run. The other thing I'm going to show you how to do is how to take readings from the sensors so that it can actually take real world information instead of this hardcore temperature and humidity stuff, which I have put in there. So I hope you guys have found this interesting or useful. If you have any questions, go ahead and type them into the questions box of the GoToWebinar control panel. I see we have one question, and does it have to be an IP address? Does the Pi have a machine name, and could a machine name be used instead? I think actually that that's the case, because that would be, and that would be super helpful, because as you know, IP addresses can change when a router resets and things like that. So I don't know off the top of my head. I think so, but I'll take a look and I'll let you know for next time. Other than that, it doesn't look like a lot of other questions, but if you do, go ahead and send them over to tfservice@alphasoftware.com. Thank you so much for joining us today. Thanks, Sarah, for being here. And we hope to see you at our next Transform Tuesday. Until then, take care and stay well. Bye-bye.